Hi everyone, my name is Kevin and I'm in charge of ARM-based network appliances product line. PUZZLE-M801 is today's topic, but before we get started, I'm going to give you a quick view on the trends and the challenges that nowadays networking environment is facing. Firstly, as shown in the curve graphic, it illustrates the network traffic flow surges very fast from gigabyte, terabyte to zettabyte. Data is 1,000 times between each unit. For example, terabyte is 1,000 times of gigabyte. So when it is zettabyte, which means 1,000 multiplied by 4 times to be gigabyte. This is quite unbelievable in the past, but it really happens now. But what's been changed in nowadays networking environment? Where does the traffic come from? Think about it. When we are using Google Maps, the phone also uploads information such as date, time, speed, route. The data goes into Google data center and comes back with a route plan that helps you away from cloudy traffic. Smartphone is one of the IoT devices that we use in our daily life and produce tremendous traffic flow. Another example is in retail field. Video and the POS and the POS would upload customers' age shopping information, such as gender, age, products they bought, ways they paid, etc. to data center. So many companies can formulate a marketing strategy according to data analytics. Even in industrial field, for example, like as well known as Industrial 4.0, real-time production data and the machine status measure data is also important to MES and the decision making on maintenance arrangement, production capacity, and the material procurement planning. Then, 5G application is next traffic exposure as more devices such as mobile or edge devices are equipped with network connectivity. All those data together becomes a popular topic known as big data. Those data will be in unmanageable volume and varieties and has to be transferred and stored to cloud storages almost in real time. As shown in the slide, volume, velocity, and variety of all sorts of data challenges nowadays networking environment. On this slide, we are talking about how those data transferred. Think about it. We want as more data as we can to precisely target our business strategies. To efficiently acquire those data, we need to spend capital and operation expenses and deploy a series of devices and solutions. With so much effort we made, we don't want those data to be transferred in public network as it's not safe. We need it in a secured and isolated channel to avoid malicious tapping, hacking, or other source of attack. Here, we simply separate network environment into two sides. One is edge side, where all data is collected from all sorts of IoT devices, and the other is cloud side, where all data is transferred to and stored. We see there are gateways on both sides to create secure channel from public network. But what happened in this secure channel and what role does the gateway play? Actually, the gateway provides VPN service, and you have to log in with your username and the password before you can access intranet. This is an ID authorization method through gateways. Then you can start to deliver messages through it. Based on IPsec protocol, gateway encodes your message and delivers. The code happens in the gateway of the other side. Encode-decode algorithm is a lot of math calculation work, which means it consumes CPU resource a lot. So maybe you have noticed that more packets transferred, CPU loading is going higher. But it doesn't mean performance is optimized. Getting is on network forwarding. From that slide, we observe the trend that more workloads are moving to the edge of the network, and the elevated degree of operation performance is required. New data plane technology plays an important role in this, which requires the combination of software and the DPTK-compatible hardware to operate together as shown on this slide. New data plane technology, well known as DPTK, which is the abbreviation of Data Plane Developing Kit, released as open source by Intel. This technology allows network traffic directly passed through to user space by kernel, which provides a way to optimize network forwarding and the software performance. Nowadays, software can operate in high performance by utilizing powerful CPU and more cores, but traditional network forwarding causes the bottleneck. New data plane technology implements optimized network forwarding and greatly increases application performance. In contrast, this slide shows the traditional network forwarding. In traditional platform, kernel path is not optimized for network forwarding. Code is too generic and the network stack is a huge part there, which results in performance gating to applications. On this slide, edge computing hardware is becoming a significant segmentation in nowadays networking architecture, as shown in below diagram. Less complexity hardware design enables quicker time to market, easy deployment with lower capital and operation expenses. This is completely different from traditional architecture that only has two layers, servers and clients respectively. Rapid growing network traffic and new technology introduced accelerates and brings the change to nowadays networking appliances. With the entire introduction of nowadays networking environment and the new technology for edge computing hardware, it must be much easier to get the point why IIS PUZZLE-M801 is a particular practical selection for edge computing hardware to perform functions such as next-generation firewall, software-defined WAN, and the virtual CPU in small and medium business, branch offices, and enterprise intranets. First of all, M801 is powered by Marvell Armada 8040 quad-core system on chip with ARM version 8 architecture, Cortex-A72, that supports fully I/O virtualization via ARM lattice system management, memory management unit, and the general interrupt control. Virtualization is the core for software-defined WAN with network virtualization functions, which allows for networking services such as virtual router, virtual switch, virtual DNS, virtual firewall to be integrated in one-piece hardware instead of applying a number of proprietary equipment. Secondly, M801 has 4 RJ45 and 2 SLP ports that are DPTK compatible through integrated packet processor, which provides centralized and unified traffic management. Thirdly, security engine offloads encoded computing from CPU. Services such as VPN, IPsec, Open SSL web service, layer-to-layer checksum offload, and CRC offload can be accelerated by security engine. Lastly, integrated IEEE 1588 precision time protocol makes M801 applicable in automation field for time-sensitive application. With regard to internal interface, M801 supports DDR4 2400 MTS on buffer DIMM up to 16 GB. 2.5-inch SSD, 32GB eMMC embedded storage, and is ready for 4G LTE and SATA SSD via M.2 key B Type 2242 interface. Furthermore, PCIe Gen 3x1 slot allows extra expansion. Software-defined network, known as SDN, relies on data plane and virtualization technology to develop various network virtualization functions. As mentioned previously, it enables various networking appliances in one-piece hardware to save total cost of ownership. In summary, PUZZLE-M801 has everything key to support with high performance and low cost. IEI has developed practical engineering and integration experience and capability on a series of marvelous solutions, including system-on-chip, Ethernet PHY, and switch, which with cost-efficient design, as well as relevant product validation capability. Besides, wireless solution, TPM, and hardware mounted IPK are also ready to any ODM opportunities. Are you ready to get PUZZLE-M801? There are two models for order. Get one to validate the performance with your application. This is my presentation today. If you have any questions, please scan to our QR code to the website. If you like this video, please subscribe our YouTube channel and click like, share, and comments on this video. Thank you. Bye bye.